We'll get started. All right, so shown in front of you is just the schedule for the next couple of weeks. A reminder that you guys have all of next week off for Thanksgiving break, so include that. We are scheduled to have our next exam the Monday when we get back, but I'm going to push that exam back till Wednesday, which I can't believe it is December 1st. So what we'll do is we'll get through about half of chapter 17 today, and then we'll finish chapter 17 the Monday you guys return from Thanksgiving break. So look for your next lecture exam on Wednesday. And like usual, I'll try to post some sort of study guide either next week if you want to study over Thanksgiving, or for sure by Monday. Also, the week that you guys get back from Thanksgiving, after Thanksgiving, you'll have another lab pickup due. And I haven't heard, if you need your lab kit mailed, let me know. Normally, we're only doing that for people who live out of state. So let me know if you need your lab kit mailed. Otherwise, plan to pick it up during that week of November 29th. And I think I posted the instructions for the pickup days during that week. So just send me a message if you have some sort of extenuating circumstance and you or someone else can't pick it up during that time. All right, so here we are, chapter 17 on nutrition. So it goes really well with our digestive system talk. I accidentally scheduled myself for a meeting in about half an hour. So we're going to get through about half of this, and we're just going to have a shorter lecture today, and then we'll finish this chapter on Monday after Thanksgiving. So nutrition, metabolism, and body temperature regulation, we'll talk about this next. Basically, we're going to be going over how your body takes in the energy that it needs, or the nutrition that it needs, and turns it into energy and the building blocks for new molecules. So nutrition itself kind of describes that process in which we take in food that's used by the body. It includes digestion, absorption, transport, and metabolism. And the idea of metabolism, whenever you see that word, metabolism literally means taking in food and breaking it down to glucose, or the simplest form, and then turning it into energy, which in our bodies is ATP. The study of nutrition will involve the study of the food and drink requirements for normal body function. So our bodies need a certain amount of vitamins, minerals, and molecules for normal bodily function. And if we don't get that, things start to go wrong. Any type of nutrient is a chemical that's taken into the body that, again, will provide energy and the building blocks for new molecules. So we talk a little bit about my plate, and every 5 years, so this is probably a little out of date, very out of date, the U.S. Department of Health and Human Services and the USDA jointly make recommendations on what Americans should eat to be healthy. And in 2011, the USDA introduced My Plate to replace the My Pyramid scheme. So maybe you're more used to the My Pyramid scheme, or you remember learning about that in school. But My Plate is a little simpler visual reminder about what to incorporate into what you eat. It's a little icon. It'll show a plate, and I'll show you a picture of it, and glass with just separate portions that represent how much of each fruits, vegetables, grains, proteins, and dairy you should try to strive for with every meal. And it just, again, tries to emphasize the importance of making healthy food choices. Half of your plate should always be fruits and vegetables. So you can look at choosemyplate.gov, which is a website to help you make healthy dietary choices. I think we all know what we should eat. It's just hard to do that. It also, okay, Choose My Plate. All right, so this is kind of, if you go to this website, you would get kind of this icon representation about how much of your plate should be one of these food groups. You know, a little portion should be dairy unless you're lactose intolerant. Fruits and vegetables should take up half your plate, and then grains and protein should take up about a fourth of your plate. So let's talk about calories now. So calorie is the amount of energy required to raise temperature of 1 gram of water, 1 degree Celsius. So calorie is an energy measurement that we use to measure how much kind of energy is required to raise temperature of water by 1 degree Celsius. And a kilocalorie is more kind of what we base our food choices on. Kilocalorie are 1,000 calories. Nutrients can be divided into 6 major classes, and these are the 6 major classes of nutrients that we'll go through now: carbs, lipids, proteins, vitamins, minerals, and water. And I usually have some students who are nutritionists, or they've studied this more than I have. So if you have any comments as we're going through this, maybe a little bit more about nutrition that we kind of cover on the surface level, feel free to add any of your wisdom into the chat so we can all eat healthier as well. So a balanced diet consists of enough nutrients in the correct proportions to support normal body functions. We have essential nutrients, which must be ingested because the body cannot manufacture or make them, or it cannot manufacture them in adequate amounts. So essential nutrients are certain amino acids, certain fats, certain fatty acids, most of the vitamins, minerals, water, and some carbohydrates are essential nutrients that we must ingest in our food because our body cannot make them or cannot make them adequately. So carbohydrates, their molecular formula contains mostly carbon, hydrogen, and oxygen atoms in this ratio, a 2-to-1 ratio of hydrogens to oxygen. So for example, C6H12O6 refers to the glucose, the simple sugar carbohydrate, and it has 6 carbons arranged in a hexagon-like structure with each carbon at a 6-pointed hexagon, 12 hydrogens, and 6 oxygens. Carbohydrates include your monosaccharides, which are simple sugars like glucose, disaccharides, when we put 2 simple sugars together, and polysaccharides, and poly means many, so that's many sugars kind of linked together. So a monosaccharide is 1 sugar, and an example of that is glucose and fructose. Disaccharides are when we link 2 sugars together. So for example, if we link glucose and fructose, we get a totally different disaccharide called sucrose, and lactose is the name of the disaccharide when we link or chemically bond together glucose and galactose. And polysaccharides are many sugars just linked together in a chain. And a polysaccharide, this is what makes up starch, grain, vegetables, and glycogen. And glycogen is the storage form of glucose, and it's usually stored as glycogen in your liver. So that's where your glucose is stored, in your liver. Simple carbohydrates have no nutritional value, and these cause weight gain. So simple sugars, you might have heard of that phrase before. So for example, this is candy, soft drinks. There's about 9 teaspoons of sugar in a can of pop soda. So the recommended amount is to use sparingly simple sugars or simple carbohydrates. Complex sugars or complex carbohydrates have a kind of a nicer connotation to them. These will include fibers that help to decrease colon cancer, heart disease. These will be your whole grains, pastas, rice, bread, and the recommended amount is to have these at every meal. A serving size is a piece of bread or half a cup of uncooked pasta. And your carbohydrates are really important because they're our short-term energy storage. Because they're made up of glucose or sugar molecules linked together, they can be converted back to glucose very quickly. And glucose is what will enter kind of our cycle called cellular respiration or cellular metabolism, which turns glucose into ATP or energy. So our carbohydrates are very important for our bodies to get glucose, and glucose in turn is important to create ATP or energy. Remember that ATP is kind of our body's money. It's our currency of the body. All our cells need ATP to function. Without ATP, we quickly die. So glucose from carbohydrates is important to have in adequate amounts. Brain cells also require glucose, so that is also important for brain cells. So your lipids then are our fats. They're usually totally or partially insoluble in water, and that means they just can't dissolve in water. And you know that if you put some olive oil or canola oil in a glass of water, they'll separate out, so lipids cannot dissolve in water. This includes your triglycerides, your steroids, your phospholipids, and fat-soluble vitamins. So vitamins that cannot dissolve in water either. Triglycerides are our most common type of lipid, accounting for about 95%. And if the fat is a liquid at room temperature, it's referred to as an oil. So that's why we kind of use the term oil to also refer to as a lipid. An oil is just fat or a lipid at room temperature that is liquid. Fats can be saturated or unsaturated. Fats that are saturated, that's where their fatty acid tails have only single covalent bonds between their carbon atoms. And fats that are saturated means that the fats and their tails can easily stack on top of each other. So they become saturated. And because they can easily stack on top of each other, they become more difficult to separate or digest. Fats that are unsaturated have one or more double bonds, so they cannot stack easily on top of each other. So unsaturated fats are usually easier for your body to break down. So sometimes unsaturated fat is thought to be a little bit more healthy because it's just easier for your body to break it down. A monounsaturated fat has one double bond, and polyunsaturated fats have two or more double bonds. So a saturated fat is what we can find in meat, your dairy products, eggs, nuts, coconut oil, palm oil. Unsaturated fats include olive and peanut oils, and polyunsaturated fats are found in fish, safflower, sunflower, and corn oil. So kind of ranking them from worst to best, saturated fats would be the hardest for your body to digest because these fats stack on top of each other and it's just harder to break them apart. Monounsaturated fats are the olive, peanut oils, and then if we have several kind of double bonds within the formula, those are your fish, safflower, sunflower, and corn oils. One thing about living in Ecuador is they have so many flowers, their biggest export is roses. I can buy 50 roses for $5 here. Another big thing I can buy for very cheap is sunflowers. They export sunflowers. So what's very common here is to use sunflower oil. So I use sunflower oil all the time. And I imagine sunflower oil in the States is a little more expensive, but I don't remember because I haven't bought it there. So this is kind of explaining then saturated versus unsaturated fat. And unsaturated fat, again, is better for us because it's easier for our body to break it down. It's also liquid at room temperature. So we'll see a lot of our oils as unsaturated fat. And then saturated fats are bad for us because, again, they are saturated. They're stacked on top of each other. It's harder for our body to break it down. And because they're saturated, this makes them solid at room temperature. Trans fats, trans just means they're processed fats and oils. They raise your low density lipoproteins and lower your high density lipoproteins. So they will increase the rate of heart disease. So these are trans or processed fats and oils. Whenever you see the word processed or transgenic, try to stay away from those. Your body, it's not good for your body either. Cholesterol is a type of steroid, and a steroid just means that kind of has a specific molecular kind of structure of kind of a hexagon and an octagon kind of next to each other. And cholesterol is highly concentrated in your brain, your liver, in egg yolks, in whole milk, in cheeses, in butters, and meats. LDL cholesterol is the bad cholesterol. So that's why trans fatty acids will raise the LDL levels. LDL cholesterol will carry the cholesterol from your liver to your cells. So it will bring, if you remember in our, I think, was it just last chapter, we talked about the chylomicrons, which surround the LDL cholesterol, lipids, and it will actually carry them to your cells. So this is bad cholesterol. High density lipoprotein, HDL, is the good cholesterol. It's kind of a molecule that carries cholesterol from your cells to the liver to be processed. You can increase your HDL levels of good cholesterol through exercise and diet. So for lipids, the recommended amount is sparingly. For saturated fats, cholesterol, maybe keep it to 1 egg yolk a day, which again, I think I had 2 eggs today already, so I've not done well there. Lipids can cause weight gain, heart disease. They can also increase the risk of colon and pancreatic cancer, and anything processed as well. Reducing fat and cholesterol. So instead you can eat poultry, fish, beans, vegetables, fruits high in fiber, use herbs and spices for seasonings instead of salt, remove the skin, which is the best part, from chicken and other animals that you might be eating. Broil, bake, and grill instead of fry. Limit creams and butter, avoid processed cheese, egg yolks, and liver. I should say limit the use of frying unless you have an air fryer, which I hear is all the rage right now because it fries with just the idea of air and isn't actually in a lipid or an oil. Your functions and lipids in comparison to carbohydrates are more of a long-term energy storage. Your lipids also insulate your body against heat loss. So we all have a layer of adipose tissue to help control heat loss, which is good. Lipids also serve as a protective cushion for organs. And cholesterol, if you remember, cholesterol is a very important part of all cell membrane structure. Proteins then are chains of amino acids. They're found in most of the plant and animal products we eat. Proteins in the body are constructed of 20 different kinds of amino acids, which are divided into essential and non-essential. And remember, anything essential is something that our body cannot synthesize. So we have to get our essential amino acids from the diet. And these are the 9 essential amino acids: histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. A complete protein food will contain all 9 essential amino acids in the needed proportions. And if it's an incomplete protein food, it will not. Animal proteins tend to be complete proteins, whereas plant proteins tend to be incomplete. Some plant-based foods such as soy and quinoa, took me a while to learn how to pronounce that word, quinoa, are sources of complete protein. So for people who are vegetarians or vegans, they just have to be careful to make sure they're still getting adequate amounts of complete proteins, because it's easy to find complete proteins in a lot of animal meats. Again, amino acids aren't stored, so we need to take in a daily supply of them. This is about 1 to 2 servings of dairy, 1 to 3 servings of nuts or beans, 0 to 2 servings of fish, poultry, and eggs, and use red meat sparingly always. Functions of proteins. Proteins are important basically for everything in the body. They help to make your skin, hair, nails, muscles. They help to form hemoglobin, which transports oxygen in your blood. They are the functional unit of all of our enzymes, which help our chemical processes to go a lot more smoother and quicker. They have important uses in immune system functions. They're a part of our muscle contractions. Actin and myosin are proteins, and proteins are a part of the cell membrane. So when we say protein, think of the individual amino acids that make up each protein, and those amino acids can have lots of different combinations to create all of these important molecules in the body. Vitamins then are organic molecules in small quantities in food, and they're needed for metabolism. And a balanced diet will give the body a variety of vitamins. If we don't have vitamins, this can result in deficiency diseases. They can be fat or water soluble. So vitamins that can dissolve in lipids or fats include vitamins A, D, E, and K. And vitamins that only can dissolve in water are the B complex vitamins and vitamin C. Again, essential vitamins, it's essential, so they cannot be produced by the body. They must be obtained through the diet. A provitamin, if you've heard that term, it's a part of a vitamin that the body can assemble or modify into a functional vitamin, such as converting in the body to the active form of vitamin D. Most of our vitamins function as a coenzyme, which will combine with other enzymes to make the enzymes functional. So the Food and Nutrition Board established this RDA, Recommended Dietary Allowance, which are all the nutrient intakes that are sufficient to meet the needs. RDAs are established or were established for different ages based on the gender, starting with infants, continuing to adults. It also changes a little bit for pregnant and lactating women. So vitamin A, also known as retinol, this is from the provitamin carotene, and it's found in yellow and green vegetables. It's preformed in liver, egg yolk, butter, and milk, and it's necessary for rhodopsin synthesis. And the rhodopsin is a protein in the eye that helps the rods, which are photoreceptors in the eye, to help you see in kind of low or nighttime vision. It's also important for normal health of all of our epithelial cells that cover and line the parts of the body, important for bone and tooth growth. So deficiency can cause rhodopsin deficiency, which could lead to night blindness, retarded growth, skin disorders, and increased infection risk. Vitamin B1, also called thiamine, is found in our yeast, grains, milk. It's involved in carbohydrate and amino acid metabolism. It's very necessary for growth, and the deficiency can cause a disease called beriberi, which is a muscle weakness, including your cardiac heart muscle weakness, neuritis, which is inflammation of your neurons, and paralysis. Vitamin B2, riboflavin. This is one of the important vitamins found in green leafy vegetables, liver, wheat germ, milk, and eggs. And when we talk about liver, I'm talking about the actual liver of a cow. So eating liver has many benefits to it. That used to be really common to eat, liver and onions. Today, I don't know how common it is if you guys eat liver all the time or not. B2 is a component of flavin adenodinucleotide, which is abbreviated FAD, which is a very important, what we call electron carrier in the citric acid cycle. If we have a deficiency of vitamin B2, it can cause eye disorders, skin cracking, especially at the corners of the mouth. Vitamin B3 found in fish, liver, red meat, yeast, grains, peas, beans, and nuts. And as we're going over where these vitamins are found, if you normally eat a diet that's rich in these foods that we're listing, then you probably have nothing to worry about. You're probably getting all of these essential vitamins that your body needs. The deficiency causes a disease called pellagra, which can cause diarrhea, dermatitis, and a nervous system disorder or dysfunction. Pantothenic acid, and I keep looking at my phone because, again, I'm so sorry, I have a phone call that I accidentally scheduled in about 10 minutes. Pantothenic acid is found in liver, yeast, green vegetables, grains, and intestinal bacteria. And this acid is a constituent, or something that helps make up coenzyme A, which in glucose production, it's involved in glucose production, forming glucose from lipids and amino acids, as well as helping to form steroid hormones. A deficiency can cause neuromuscular dysfunction and disease, and fatigue, Biotin is a vitamin found in liver, yeast, eggs, and intestinal bacteria. It's really looking like we should all start to eat more liver. How do you prepare that? I'll have to look up a recipe. Fatty acid, so biotin is involved in creating fatty acids and nucleic acids, and movement of pyruvic acid into the citric acid cycle. And moving pyruvic acid into our citric acid cycle is one of the major steps in forming ATP from glucose. So that's a part of our cellular metabolism. A deficiency can cause mental muscle dysfunction, fatigue, as well as nausea. Vitamin B6, again, livers just keeps popping up here for us, guys. We might have to try it. Fish, yeast, tomatoes. It's involved in amino acid metabolism. So that means breaking down amino acids. Deficiency can cause dermatitis, which is an inflammation of the dermal layer of your skin. So inflammation of the skin, retarded growth, and nausea. And then folate is found in liver, leafy green vegetables, intestinal bacteria. It helps with nucleic acid synthesis, hematopoiesis, which is the formation of red blood cells. It will also prevent birth defects. So often, if you have ever been pregnant, if you've taken your prenatal vitamins, you see that they are included in the other vitamins is folic acid, which is really important for preventing birth defects. And a deficiency can cause macrocytic anemia, where they're enlarged red blood cells, and spina bifida. And this is the big one. By taking folic acid, it helps to decrease the risk of spina bifida, which is in newborns, if their spine doesn't form all the way, and the spinal cord can kind of peek out a little bit of the vertebra. So I'm going to go ahead, and I didn't mean to stop share there, but I think I'm going to pause there. So we got through about 40 slides, so we're about halfway through. So I think I'll pause there. Again, if you just joined us late, I'm just stopping a little early. We'll continue this lecture on Monday after Thanksgiving. So enjoy your Thanksgiving break, guys. If you have lab on Wednesdays, please still go to lab today. But the next lecture exam will be the Wednesday after we get back from Thanksgiving, and look for a study guide or a study sheet on that Monday as well. Magnesium, magnesium might not necessarily be a vitamin. And I don't know, Kathy, you guys asked a question magnesium is a mineral. So we'll talk about minerals in about 5 slides. Good question. Magnesium constitutes a mineral. Good question. Have a great day, guys. Have a great Thanksgiving break to you all. I hope you guys can enjoy the time off and have a good weekend as well. So we'll see you back in about 10 days.